In all the lessons that we have covered so far, the projectile has landed back on the ground. And we also discussed a case where it landed on top of a building. Now we launch a projectile up an incline having an angle of inclination of beta. And all of a sudden it seems like the level of complexity has increased. But don't worry, we'll go through this process step by step, and by the end of this series on projectiles launched on inclines, you'll find that it isn't as difficult as it seemed initially. When a projectile is fired here, the launch angle of the projectile will obviously have to be greater than beta, the angle of the incline. So let's call the angle of launch with respect to the incline as alpha. Then the angle of launch with respect to the ground would be alpha plus beta, which in all the previous lessons we've been referring to as theta. So alpha plus beta equals theta. And what we are interested in is to find the range R, not along the ground this time, but along the incline. Actually, the presence of the incline causes some psychological difficulties in our thinking. So let's remove the incline and rephrase this problem. Now it more or less appears like what we've been used to all this while, that is, a projectile launched from the ground. The presence of the incline will not cause any change in this trajectory. It would follow the same path with or without the incline being there. It is fired at an angle of theta, which is alpha plus beta, where beta is the angle of the incline and alpha is the launch angle with respect to the incline. But with respect to the ground, the launch angle remains theta. Now this seems like more a problem that we had encountered earlier. And if you remember, here we had launched the projectile on top of a building. But in that lesson, we knew either the x displacement or the y displacement, and then we simply applied the trajectory equations to get x or y, which were one of the unknowns. Now we have to consider this topmost point as the point where the projectile lands back on the incline. So here we can think of B as being on top of the building, and since we have called the distance between A and B as the range R, let's obtain the x and y displacements in terms of R. So we are trying to transform this problem into some form that we are familiar with. Now we have the trajectory equation, and we have expressed the x displacement and the y displacement in terms of the angle of the incline beta. So x is r cos beta and y is r sin beta. So let's plug these expressions for x and y into the trajectory equation. The good news at this point is that we are done with the physics part of it. From here, it is purely mathematical manipulation. We get this rather complex looking form after substituting for x and y into the trajectory equation. For y, we have substituted r sin beta, and for x, we have substituted r cos beta here and here. Now let's bring the r terms over to the left-hand side. Now we expand the left-hand side and we can identify the trigonometric pattern of sin A cos B minus cos A sin B, which simplifies to sine of A minus B. So A here is beta and B is alpha plus beta. And beta minus alpha plus beta reduces down to minus alpha. Now from this simplified form, you can see that r is common on both sides and one of them would cancel out. So would cos of alpha plus beta. It's present on both sides. That also would cancel out on one side. And we arrive at the range r as 2v0 squared sine of alpha cos of alpha plus beta over g cos squared beta. Once again, beta is the angle of the incline and alpha is the launch angle with respect to the incline. And you can compare this with the range equation that we had derived without the incline, which was v0 squared sine 2 theta over g. In other words, this is what we would get if the angle of incline beta was 0, and then alpha would be the same as theta, as if we were launching the projectile from the ground without the incline. There is another approach to this problem, and we'll discuss that in the next lesson. In order to find the range of the projectile along an incline, we need not add any new concepts. We simply transform the x and y displacement in terms of the range and plug that into the trajectory equation.